So today we'll have a mock interview on SystemVerilog, verilog and protocols. Okay.
Yes.
So first of all, can you introduce about yourself?
Good afternoon, ma'am. My name is Ravant. I am from Visakhapatnam. I have completed my BTech in SRM University in Electronics and Communication Engineering. I am very passionate about VLSI. During my academic journey, I have explored through digital electronics, verilog, SystemVerilog. Now I am currently pursuing training at ProVLogic. I'm studying these languages, verilog, SystemVerilog, and digital electronics. And during my journey, I have done some projects like FIFO memory, ATM machine using FSM, and I have also covered the protocols, APP protocol, I2C protocol, UART protocol, and AHP protocol. And I'm currently seeking opportunities in VLSI industry as a design verification engineer.
Okay.
Good afternoon. I'm Abhinaya. I came from Marchella. I completed my graduation in Missouri Institute of Technology, Bhimavaram. I'm very interested to join the VLSI to explore and to learn to learn new things in the VLSI. So I learned DLT, Verilog, and SystemVerilog. I have done some protocols projects in the VLSI, UART protocol, I2C, APB, AHP, and done some projects like ATM machine, FSM, etc.
Okay. Can you explain what is the major goal of coverage in SystemVerilog?
Basically, when we write the code in the design, we have to know how much our design was covered. So for the coverage only, we are writing the coverage. We know how much percentage we got for our design. If 100% got means our design is perfect to know. If you not get the 100% coverage, means we have to check in the design and instantiation process and bins. We have to check and we have to rewrite the logic and we get the coverage. So coverage is the main criteria for the design.
Okay. So in design, especially what we are verifying with the coverage?
The connections, port connections, instantiation process checking correct or not. Whether we are giving the correct inputs, when we are connecting, it getting correct or not. We have checked the port connections.
Okay. Okay. What type of coverage it is?
Functional coverage.
Mm-hmm. Functional coverage means is it related to port connection checking?
Basically, coverage are two types, core coverage and functional coverage. Core coverage means tool only automatically generate. So functional coverage, we have to use a different. We write the coverage basically two types: data oriented and SystemVerilog as control oriented. Data oriented means the cover group, cover point based on the bins cover group. We write the code. In control oriented, assertions, like SystemVerilog assertions.
Okay. Okay. But functional coverage means not about checking the instantiations or port connections. Functional coverage means just how much the design functionality is covered. That's what we need to verify. For functional verification, you are writing the test bench, right? If you go for very complex designs in SOC level or IP level, we write lot of test cases. Do you know what is meant by a test case?
Test case means for test bench we are writing test case.
What is the difference between test bench and test case?
Test bench means we will give the input stimulus to the design so that it will generate the output. Test case means we will take the output for each input and we will check whether it is correct or not.
Okay.
For every input, we will check the output whether it is matching to the expected output or it is if there is an error or not.
Mm-hmm. Okay. Actually, test bench you already written in Verilog and even SystemVerilog. Okay, test bench is a overall it's an architecture or its overall scenario. What we need to verify the functionality of a design. Whereas a test case, whenever the complexity of designing is increasing, there are a lot of features we need to verify. Suppose AHP protocol. In AHP protocol, we already designed some burst transfers. In burst transfers, there are increment and wrap. Again, in increment, we have increment for 816, wrap for 816. So here nearly there are 6 features. For these 6 features, we cannot write a single test bench. We need to verify these 6 features with the different 6 test cases, with the different 6 scenarios. That's where we are dividing the entire test bench into the number of functionality, number of cases, number of features, so that every feature we can verify perfectly. That's what the test case means. Okay, every test case have its own feature. We need to verify the functionality of every feature. So we are writing a lot of test cases in real time. Okay, so why we are using the coverage here means maybe sometimes we may miss to verify something in the design. Okay, you may miss the burst transfer increment 4. Without verifying increment 4, you verified everything. So increment 4, we don't know, because we think like as a verification engineer, our goal is completed 100% verification test cases are passed. But when we get to know that thing, whenever the coverage report is not hitting 100% because that particular functionality is not verified, so at the coverage, the bins will not hit.
Yes.
Right. So whatever the holes are there, what is the difference between bins and holes?
Bins means implicity bins, explicity bins.
Mm-hmm.
Implicity bins means manually, automatically. Explicity means we write bins with keyword and one variable name. We writing manually to check the bins.
Okay.
Whole means you hit or fail. It gives the kind of statement.
Okay. What is meant by hit a hole?
It means pass condition.
Holes means?
When it is not hit, then it is false.
When it is not hitted, you will get the holes. Holes also you need to convert into the hits.
Yes.
Then our coverage report will increment. Okay. So coverage is nothing but whatever the test is not verified, functionality of a design is not verified, then we will get to know through the coverage.
Yes.
Okay. So what type of coverages bins are there? Cover bins or cover groups. How do we write?
There are implicity bins, explicity bins, ignore bins, illegal bins. First, implicity means automatically it will generate. Explicity means we have to give manually bins. Ignore bins means whenever we don't want that values, it just ignore it, but does not throw error in runtime. It will give 100% coverage. And illegal means whenever we don't want that variable particular values, it will throw an error like runtime error, like 0. If you don't want 0,5 values in the variable, so 0,5 neglect and it will throw an error. Then 0,5 will throw an error. Like means cross coverage bins means each combination will cover the cover points. Like if you take the 2 variables within the bit range, so the bit range should cover each variable manually.
It will take the all possible values
combinations of the cover
variables.
points.
Okay. In cross coverage.
Cross coverage.
Okay. So what is mean by auto bin max in coverage?
Auto bin means explicitly it is an implicit bin. It will take by its own and it will cover all the possible values of the variable.
Okay.
We should not declare bins explicitly.
Okay. Suppose if I given a test case for you to verify the coverage, suppose can you write an example? There is a data with 4-bit size. In the 4-bit size, I have written a test random values, or I have generated the random values as 5, 6, 8 and 10. Remaining cases, I'm not generating any random values, so it is not covering in the test bench. So if you write the coverage, suppose if you take as a bins as a 4 means what it is mean? 4 bins. How it is divided?
Bins as 4 bins. It is a 4-bit number. It is divided into 4 different parts of equal size.
Okay. So how much percentage of coverage you will get from this?
5, 6, 8, and 4-bit number.
You also can try.
Only 2 bins got hit now. In that 1 bit hit 2 times. So out of 4, only 2 bins got hit. So it is 50% coverage. We got 50% coverage.
How many hits?
Only 2 bits. 2 bins.
Each bin, how many hits?
Each bin, bin 1 and bin 2 are hit 2 times.
Bin 1 and 2. నేను ఇచ్చింది ఏంటి 5,
5, 6, 8, 10.
8, 10. So 5, 6 will come in one bin. That is second bin.
Yes.
8, 10 will come in third bin.
Yes.
So bin 2, 3 both will hit.
Yes.
Bin 0, bin 4 will not hit. Bin 3.
Yes.
So 50% coverage. Okay. In each bin, how many hits? How many hits means what? Here?
How many times hit?
Bin in bin 1, even if I give only 5 also it will hit. But 5, 6, 2 times it is hitting. That means number of hits is 2.
Yes.
In bin 3 also number of hits is 2. Even if I give 1, 8, okay, it will hit. But number of hits are more here.
Yes.
Like that you need to observe. Even if it is hitting, how many hits, how many number of hits we got. Okay. Okay, fine. In which cases we may not get the 100% coverage report. Suppose even if we return 100% test cases according to the design, but the coverage is not hitting 100%, then what we need to do?
We have to remove the unwanted test cases.
Sometimes bins ranges also cannot randomize properly.
Okay. Okay. Good. Somewhat. In most of the industry cases, if you see, there will be some legacy signals. You know what is legacy signal? Before project, whatever we use, if we get the same signals to the next project, like old signals.
Yes.
Sometimes if there are legacy test cases or legacy bins or signals, there also we will get the coverage not 100% coverage. So that time we can remove or unwave of the cover bins. Okay, that is one particular scenario. Even sometimes we will face lot of issues with the coverage commands internally while uploading the coverage and extracting the coverage. There will be lot of issues. That will be internal coverage issues. Okay. Can you tell me what is meant by assertion and what is the requirement of assertion in test cases?
Assertion is a set of rules. When we don't want to hit some kind of test cases, when we don't want some kind of output, so we set some rules so that when there is an error or any kind of unwanted test cases, we will throw the error now. We will throw the severity level.
Is that correct? What is the need of assertion? How we write the assertion?
Assertion we will write by property name, and if the property is hit, we will throw the error, like it is based on the severity level. Sometimes it may be fatal error or it is based on the severity level. If it is low severe, then we will write a dollar info, and if it is highly severe, then we will write the dollar error.
Okay, dollar
Error.
error.
By default, dollar error.
Okay.
Yeah. Assertion.
Okay. So, what is the difference between coverage and assertions?
Assertion to check the functionality of the design. It's validate the design.
Suppose for every clock edge, the output is getting correctly or not. Like the design validation, we use assertion. Whereas coverage, functionality verification, how much functionality has covered. Okay. So coming to the protocols, you have done your protocols, I2C, APP, AHP, and AXI. AXI is still going on. Okay. In your protocol, first of all, what are the difference between SOC protocols, on-chip protocols, bus protocols, low-speed peripheral protocols, high-speed peripheral protocols, memory protocols, interface protocols, and there are debug protocols. What is the difference between all these protocols and what are the major classification we have?
The main difference between the SOC protocols and the peripheral protocols is the usage. In peripheral protocols, we use serial communication, whereas in SOC protocol, we use parallel communication for high-speed data transfer. And in peripheral communication, we use protocols like I2C, UART. And in SOC level protocol, we use APP, AHP, and AXI protocols.
Okay. Still, what are the memory protocols? What are the debug protocols we have?
Memory protocol, Ethernet.
Memory protocols means we use AXI to transfer the data between the processor and the cache memory, and AHP for transferring the data between the SOC components like memory and digital signal processor, or in between the components of processor we use AHP protocol, and APP protocol is used for transferring the data to the peripherals.
That's like bus protocol.
Okay. Can you draw a SOC and how these protocols are connected? What is the major difference between AXI, APB, and AHB? And can you tell me what is the difference between intercommunication protocol and intra-communication protocol?
Intercommunications, two devices, we can connect two devices. In intra-communication, one device, connection only at one device.
Okay. What are the protocols?
I2C, intercommunication. UART.
Inter means within the chip or outside the chip?
Within the chip, inside the chip. Inside the chip, I2C.
Inter means outside, not within. Inter, just remember about international. International means outside. Around the world, outside India, international. Intra means within. So, I2C, SPI, these are within. Within a chip, we use to transfer the data, and serially that to very low communication speed. Whereas a UART is device to device. Suppose this is the laptop. There is a mobile phone. Here there is a UART or USB protocol. And here through USB protocol, we are connecting mobile to laptop. That is inter-system protocol. Inter means outside device to device. Okay. Intra means within the chip. In laptop, there is a chipset. In this chipset, nothing but SOC, whatever you have drawn. In that, we have parallel communication protocol, like bus protocol, or we can also call interconnect, AXI interconnect. Again, in that we have coherent interconnect, non-coherent interconnect. What is the difference between coherent interconnect and non-coherent interconnect?
Coherent interconnect means it is very high speed data transfer. Like it is very sensitive. It will transfer the data to the memory and processor elements. No? Whereas incoherent for processor and to the other subsystems.
First of all, in SOC, we have processor-related subsystems and non-processor-related subsystem. Processor-related means CPU, graphic processor, audio, video processor, image processor. All these things comes under processor. What will be there exactly in the processor?
Question, sorry.
What will be there? Like what sub-blocks will be there in the processor subsystem?
In processor subsystem, we have like it will fetch the instructions and execute the instructions. No?
Where it happens? In which block it happens?
Receivers.
What receiver? In processor, there will be core cache memory. Okay, so that's why if you see SOC block, if you remember, there will be orange color interconnect and side there will be green color interconnect. Green color interconnect, orange, both are AXI only. Why do we use AXI protocol there?
In high speed.
So processor works at a very high speed in terms of gigahertz. So AXI protocol is one of the very high speed bus protocol. So that's why we use AXI at a processor level. Coming to the small peripheral level, what protocol is used?
AHB.
AHB, APB protocols are used. Okay. So when we are connecting with the core and non-core, there are two versions in AXI. Core related, non-core related. So as we have core in processor, we have a coherent AXI. Remaining entire system is a distal system, like normal architecture or hardware. These are non-coherent architecture. So we use non-coherent AXI protocol. We have two terms in that. Okay. So that is what about bus protocol. Coming to the serial communication protocol, I2C, SPI. I already told what are the major application of I2C protocol.
When we connect multiple slaves to the multiple slaves and multiple master, we communicate through I2C protocol.
Simply microcontrollers. When we are connecting multiple microcontrollers, sensors, different slaves, we use I2C bus. Okay. So coming to the UART protocol, can you explain the frame format of UART protocol?
First, in UART protocol contains start bit and data bit, parity checker or generator, and stop bit ones. If you take the start bit 1, and the word data can be defined 7 to 0, D7, D6, D5, D0, and 1 bit can goes to parity for generator and checker, and stop bit means 0. Vice versa. Start bit 1 means stop bit 0, start bit 0 means stop bit 1. This is the frame format.
Okay.